Hi guys, I have selected a question from 2013, question number 44. It's basically from the question is from Bernoulli's principle. It's a cylindrical shaped tank, two different liquids of height h1 and the height h2 is up and h1 is down, and the density d1 and d2 is given. And this is d1 is greater than d2. Anyway, d1 will be downwards in the lower part, or downwards lower part. Right, I'll just read the question. A cylindrical tank having a very large diameter contains two immiscible liquids, densities d1 d2. The tank has a small hole closer to the bottom. If the heights of the liquids at the certain instant h1 and h2, what will be the speed v of the liquid ejecting out of the tank at the instant? At this instant is an important point. So here the velocity of the water, that is they have marked as v. Alright, neglect the surface tension effects and assume that the liquid is non-viscous. Okay, the liquid is non-viscous means in the other side they wanted you to use the Bernoulli's principle. Okay, now you see you can just find some streamlines of liquids. Here see, and this is something they have given. They say something hidden in this question, that is the diameter of the tank is very large. The diameter of the tank is very large compared to the diameter of the hole. You know that Q dot is equal to AV. So when cross section increases, velocity decreases. Here the cross section is very large. The velocity of this surface can be neglected. That is the thing. Okay, now you have to select 2 points from a specific streamline. When you're trying to use this Bernoulli's equation, half P plus half rho V square plus H rho G is a constant. Guys, here say you have to select a specific streamline and the 2 points should be in a specific streamline. So in A, you can find what is pressure, what is half rho V square, what is H rho G. That is equal to, in the same streamline when is ejected, what is pressure, what is half rho V square, what is H rho G. Okay, I'm just considering this as my zero potential energy level, and here the velocity is almost zero. I told you why. The surface area is very large. So here you don't have the kinetic energy per unit volume, half rho V square, but you have H rho G. Since zero potential energy level is this is in the zero potential energy level, so you have potential energy per unit volume is there in this area, potential energy. So let me check how it works. Now I just used the Bernoulli's principle. Consider A and B. A comma B are the points. At A only the atmospheric pressure is there. At A, atmospheric pressure. What is half rho V square? Since velocity is zero, it's zero. H rho G. Potential energy per unit volume due to the height it comes. Compared to B, A and B, A will be in a certain height. Okay, H rho G. H1 rho 1 G plus H2 rho 2 G. I'm sorry, not rho 1, D1. D2 G. That is equals, when it's just ejected out, you have only the atmospheric pressure. Half rho V square, yes, you have half rho V square. Please, rho means the density of the liquid. At this instant, which comes out, D1 or D2? D1 comes out. Why? At this instant means D1 downward. So you have to mention D1 here, D1 V square plus H rho G vanishes. You know why? H rho G means from zero potential energy level. What is the height of B? It is zero. From zero potential energy level, what is the height of A? H1 and H2. I have mentioned here. So here H rho G part for B is 0. It's not hard. Pi get cancels. H1 D1 plus H2 D2 times G. that is equals half d1 v squared. You can multiply by 2 and you can divide by d1 too. 2 times h1 d1 plus h2 d2 divided by d1, that is v squared. When you divide individually by d1, here this d1 will cancel, here you will get as a fraction h1 plus h2 d2 over d1. So this is v squared. So v is equal to square root of 2 times h1 plus h2 d2 over d1. So this is the answer. Let me check. Hope, yes, answer is fifth answer. Hope you understand. If you have any doubts, you can even comment me. And if you wish to do any questions from the past papers, if you didn't get an idea about how to do those questions, please do comment on that. I'll try my level best to help you. Goodbye. Bye.